we wrote a program that would read in this code and figure out what the unused variables are of this program. And it did that by, it used a package called sprima to parse the JavaScript. And then the result of the parse is an AST. We had it spit out the AST into this large JSON object, basically. And then we wrote a recursive traversal function that can traverse all the AST nodes in this tree. And then we also made like a generic traverse function, which we can pass in a visitor function and customize what we're going to do with the traverse function. And at the end, we made a function that finds all variable declarations, made a function that finds all variable references, made them match, and if the ones that are declared but not referenced, those are unused, and that worked out pretty well. This time, I thought we would do something seemingly very different, but in reality, very much the same, which is we're going to write a disk cleanup program. So one time, I was looking at my disk usage, and I realized a large % of the used disk is due to my node modules folder in various projects I have. And I do a lot of little experiments. So for each one I make, it's going to be a node modules program. And it ended up building up a lot of just disk usage. And I wanted to clean them up. So how would you do that? Let's try something here. This might actually be a fun thing to follow along at home. I think I'm gonna have like some of you pair with me. But if you want to follow along yourself, you're welcome to as well. It might be fun because everybody has different contents on their disk. And it might be fun to see like unleashing this on what you have. Let me see. So the first thing you're gonna do basically is I'm gonna probably use my another folder. I don't have other folder. I'll probably use my playground folder. First of all, anyone want to pair with me? Let me ask that first. No? Bueller?
I'm taking a more passive role today because
I would.
Okay.
Trying to simultaneously balance some work, but thank you, Toast.
Okay.
Yeah, same. I'm trying to multitask. Sorry, see in the sprint.
Okay, that's fine. That's fine. Okay, I'll just do it. First, let me make a little startup program. So I'm gonna do process start args. In Node.js, you use this to take in command line arguments. I think usually file path. I'm gonna take in as a parameter a file path, and then let me print it out. Let's see what that is. Okay. So maybe I'll do like, I have a playground directory, which I put a lot of my experiments. Okay, it's actually the second argument that I want. Okay, so this is argument 0, node is argument 0, this cleanup.js is argument 1, and then this playground directory is argument 2. So I'm going to have that passed in, and then I'm going to use this file path and try to traverse the directories inside this playground. Yeah, let's go ahead and do that. So the first function I'm gonna use is the reader. Is the reader function, and this lists the contents of a directory for you. So I'm gonna do say, and also I'm using the promises version of the file system. So I'll say fs.reader, the given file path. And then because this is the promises version of the library, I'm gonna await. And then I'll end up with a bunch of entries.
Remind me what both argv is and why you're accessing the second or index 2 of that array.
Oh, yes. Okay. Let's complete this thought first. So I just read this file directory, and it gave me all the things that are in that directory. Oh, so sorry to answer this question really quick. So basically, this is process.argv is all of the is basically your command line command. This guy. Node this cleanup.js users airport home playground. It's a list of these strings of your command is what it is. So if I print this out, this is what you see. Oh, actually it has resolved node to the specific path for node. It has also resolved the location of my JS script. Does that make sense? So I'm just grabbing the third one because the third one is the parameter into my program. And or the third, I should say the second one if we use zero indexing.
And what were 0 and 1 again? Sorry.
0 would have been that the location of node, and 1 would have been the location of my program.
Oh, okay.
Yeah. So
if I'm not mistaken, that's consistent across CLI interfaces. Like the first argument is always the path to the program that you're running.
Yeah, it's slightly confusing sometimes because like in some languages it would be shifted, like 1 would be the name of their program because there's no node. Like if it's a C program, then the first thing in the list would just be the program itself, right? There's no other thing that you use to run the C program. It's a binary already. So, but yeah, for Node.js, I think this is consistent. Okay. So so this is the way I'm gonna use. And often when I write code like this, I would write, hey, if you didn't provide a file path, I'm gonna print, hey, please provide a file path, so that if you forget, then it'll tell you that. Okay, now basically what I really want to do is, okay, I printed out the entries of this directory, but I actually want to recurse. So as a first task, let's recurse through all nested files. Maybe I don't do it to everything because there's quite a lot of stuff in there. So maybe I do it to lively kernel or something. So this is everything in lively kernel, but we want to recurse through. If it's a directory, we want to drill down. So again, this is where we use recursion. So I'm going to write a traverse function where where the starting point of the traversal is going to be some file path. And I'm going to make this one an async function because the mechanism of the traversal, which is this reader function, is async. So if I want to be able to use reader inside my traversal function, I have to make my traverse function async as well. Okay, so I'm going to actually move this in here and say read the entries. And then now, once I have these entries, I'm going to for each entry of entries, I'm going to make the entry path. I think in Node, you're supposed to do it with path.join. So like path.join my file path and then entry. And then that would give me the entry path. I'm connecting this to that, basically. So that's the entry path. And then I may traverse or I may not. How do I know if I want to traverse into the entry path?
You want to check whether it's a directory, right?
Yeah, that's exactly. I want to check whether it's a directory. How do you check if something is a directory or not? Oh, there's this stat function. Yeah, it's there. Stat equals stat, give it a path. It'll give you back a stats object. What is a stats object? Well, stats object is an object that has all these things on it, including the inode number. I'm not going to talk about inode, but it does have like the modification time, creation time, access time. So that's useful actually if you're making a build system or something. But what it also has is these methods, including is it a directory and is it a file? So that's what I'm going to use. So I'm going to say, hey, let me get the entry stat.
Do I have a higher level question about
Sure.
this stuff, especially like seeing some of the properties on that stats object? Like in your experience, is this like the way that Node interacts with the file system? Is this like pretty standard if you were to use a different language to do that, or maybe even like a script, like a shell language? Like these properties and stuff, is this like pretty standard between different areas?
So, well, yes, it's so there's difference in terms of like different operating systems have slightly different terminology and maybe even functionality, but Node kind of had to normalize it across different operating systems because that's one of Node's selling points. It can run on the all the different main operating systems. I thought inode was a Unix terminology, but I'm sure Windows has something that's equivalent to it. It's essentially the identifier for that thing, whether it's a file or a directory. There has to be an identifier in the system that tells the system, oh, this means that specific thing in the file system. Block size. Let's not get into that. That could take a while. But yeah, these access time, creation time, etc. Last access, last modified time of creation. That exists in all the operating systems, so we can do that. I don't know what that is. I don't know what's def. And yeah, size. That's the size of a file. I don't actually know what the size of a directory means. I'm sure it takes some space to store a directory node on the file system, but I don't know what that is. Maybe we can check that out later. But yeah, this has been normalized across the different systems, and
Cool.
They work on all three. So what I'm gonna do is I'm gonna ask, hey, is this a directory or is this a file? And what if it's neither of those? I don't know what that means, but I'm not gonna worry about it. I haven't came across a case where it's neither of those. I'm just gonna throw an error and not worry about it. And if I'm wrong about that, I will get this error. Okay, so if it's a file, what should we do? If it's a directory, what should we do?
If it's a directory, it's recursion time.
Yeah, let's recurse. That means call ourselves. And we're gonna have to wait because we are async. So, and we have the entry path already handy. So that's nice. Are we even returning anything? I don't know that we are. And then if it's a file, what should we do? Should we do anything even? We probably at some point we want to introduce this visit function exactly like we did last time. Let's go ahead and do that. And then similar to last time, we're just gonna call visit right here. Let me think. One thing I'm thinking about is it would be useful, like you would call this like traverse the path in file path, and I'm gonna make a little visit function that is gonna receive the file path like this. Well, you know what? Let's just do this first. Get this much working. So let's say I just print out the file path visiting. Okay, so we're gonna have this visit function. It's gonna visit every file or directory within this subdirectory. Do I have to do anything if it's a file? That's a question.
What's the goal of the program?
Oh, for now we're just gonna write a generic traverse function, but the overall goal of the program is original. I actually haven't said what it was, but my original goal was I wanna traverse into my my subdirectory where I have a lot of programming projects, and I want to find see if any of them have a node modules directory in there, and I want to see if I can delete them. And my criteria was if I haven't touched that project in over 2 months, I'm gonna delete that node modules folder.
Nice. Okay.
That's cool.
Does that sound like a plan? Like that's very practical. You might actually want to do this. you might actually. And when I did this, actually, I saved like 40 gigs.
I would say, I mean, a great first step always is printing something.
Yeah, but for now we're just writing a generic traverse function, exactly like we did last time with the ASTs. And yeah, let's just print something, and let's just try this, see if this works. And I'm just gonna do it inside this subdirectory. Visit is not a function. Oh, I forgot to pass visit to my recursive call, I think. There. Okay. So I started in the lively kernel directory, and it traversed. Oh, it actually did not print the files. I guess we should traverse, even if it's a file, I should call traverse on it just to get visit to be called, right? Yeah. Or maybe just call visit on the entries, on the entry path here.
That seems reasonable.
Oh, wait. I'm having second thoughts, actually, about this structure, because should we even bother doing read dir? Because we don't even know if it's a directory here, right? We should only read dir if it's a directory, right? Does that make sense?
Yeah, for sure. So
Yeah.
you'd want to move that entry stat line.
Yeah, so I think what I should do is, yeah, this whole thing should actually be inside of that, but which means I have to do a stat on this guy. So I'm just to make it less confusing for you, I'm gonna start over, but we can use bits and pieces from here. Which also, by the way, it's probably good advice in many cases. Like if you're the mess that you made is confusing you, you probably just want to ignore it and start over. So what I'm gonna do is do the stat thing first, but not to one of the entries. I'm gonna do it to myself, and then I'll get my stat. And then, what is nice is now I can actually give the stat to the visit function, because that might be useful for the visit function. But now I can say, hey, if I am a directory, then I want to read dir. And then I'm gonna traverse. Wait, I'm gonna do this for loop. Generate this entry path. Traverse the entry path. Pass in the visit function. Await it. That actually looks pretty good. If do I even care to check if it's a file?
Is file path and the traverse function already joined, or is it just a fragment?
Where?
That parameter that you have highlighted?
Oh, this one. Yeah, it's already joined here.
Gotcha. Cool. Okay.
Yep.
It's a mistake I make all the time. So just double check.
Yeah. I actually think there's nothing to do if it's a file or not. And even on the else clause, there's also nothing to do. I mean, I could throw this error, but or I don't have to either. Yeah, I actually think there's nothing to do if it's not a directory. So let's see if this works. Yep. Yeah, that's looking good for me. There's a lot of files in this lively kernel project. This is not my project. It's like Dan Ingles' JavaScript clone of Smalltalk or something. So, okay, I think this traverse function works. It even drills into the Git directory, which begs another question. We probably also, you remember last time we said, hey, you can return false from your visit function, and then we won't traverse further down that node. We can also use that, and what we can use that for is to ignore directories like the Git directory, right? And say, hey, if this directory name is .git, return false, and then it won't traverse down into the Git directory, right? So that's useful. So what I'm gonna do is, I think there's a function in Node.js called base name, which we can use, which just means, right?
I think it's under path.
Oh, yeah. Thank you. That's why I couldn't find it. Path. There. All right. So base name is gonna return you like the name of your file, discarding the directory portion of your file path, basically. So the reason that would be useful is I want to know if the base name is .git here. So let's do that. So path.base name of file path. I'll say, hey, if that is .git, return false, and then I want it to stop the drill down of that directory. Otherwise, I'm not going to return false. So now I can say, hey, if you return false, I'm just going to early return here. Okay, so it went through everything. Yeah, but it did not go into the .git directory. So that worked. Yeah, maybe we do this. Okay, so now we have this generic traverse function. I think it works. I think from my brief testing, I think it works. We can use it to do a variety of different things, and that's very powerful. Just like last time with the AST, we used the traverse function to do two different things. This time we can use this same traverse function to do a variety of different things. So one thing you might want to do is, hey, I want to calculate the disk usage under this directory. So the way you can do that is like I'm gonna make a calc disk usage. Let me try that. So calculate disk usage, I'm gonna traverse. I can use an arrow function. So remember the stat function has a size property on it. I don't know if you remember that. Fs stat. Oh. Stat. Fs stats. Yeah, it has a size property. And I'm gonna do stat size. I'm gonna await this because it's async. And I'm gonna have a total size out here. And I'm just gonna add to it and return total size. And assuming this visit function will go through every single node in the subtree, we'll end up with the total size here. So let's try this. We might also maybe print out the size of each node. That might be a good diagnostic thing. Okay, so I'll say I forgot to await. Okay. That's cool. What is the unit of the size? Just byte?
I think
guess-
it's bytes, yeah.
Yeah, I think it's just byte. So that means this directory contains 89 megabytes worth of stuff. That's substantial. But it would also be cool to like sort it, rank it, and see what the large files are, for example. That would be a cool thing to do. I wonder also whether, what's the size of a directory? I think that's a directory. So the size of this directory is 160. Does it matter? Why do directories have different sizes? Maybe because they have different number of entries. Maybe they store the entries inside the directories. Does that sound right? Reasonable? Does anybody know? The ones that have more things in them, like as direct children, are probably going to be larger directories. That's my guess. But yeah, so we have a way to like ask, hey, how much is this eating up? How much disk space is this eating up? So that's cool. Now we might the next thing we might do is like, hey, well, I wanna look at node modules directories, and so I happen to know in my playground directory, I probably have like a lot of Angular projects, test projects. This one may not even have a node modules folder. Oh, this one does. This one has a node modules folder. So if we drilled into this one, we drill in there. Oh, wow. First of all, it got so much stuff in it that it's taking a long time just to run this traversal. Now the printing out of stuff, let's slow it down a little bit. And then doing the stat on every single file also slows it down a little bit. But yeah, there's a whole bunch of stuff in here. What I want to know though, there it is. So there's 224 megabytes of stuff. What I want to do though, what I want to know though is how much space is the node modules folder taking up? So how can I get an answer to that using the code we already have? Basically, given this directory, I want to find any node modules folder inside it, and then I want to be able to tell how much disk space is that node modules folder consuming.
You would want to create a new visitor that basically accumulates file sizes. And once you get to the folder that's named node modules, you don't enter it with the original visitor, but send in the file size measuring visitor.
Yeah, that one. We already have it. We already have this. Yeah, you call this guy, and then it'll send that in. So we do a traversal. Let's see. Okay, I'm gonna do what you said. So we're first gonna traverse on the given path. and it's gonna get a stat. Okay. And then I want to be able to tell, is this a node modules folder? So what I can do is if stat is directory and path base name of the file path is called node modules. I do something to it. What do I do? Danny? What do I do to it?
This is when you would traverse it with your calc disk usage function, right?
I just call it calc disk usage. No, I probably want to await that. And then what?
This is tricky.
You
need some way to recursively accumulate that total size, right? Because you don't know how deep the file tree is going to go, and you need to keep that number alive in between the recursive function calls. But you also don't necessarily want to have to add a parameter to your function, because then you have like a non-standard interface.
Wait a minute. I'm not totally following you. Wait, I need to keep. What you're saying? You need to accumulate.
Yeah. So you need to not just measure the files that are in the root of your node modules directory. You need to measure the files that are in subfolders and subfolders and subfolders and so on.
Oh, but basically the node modules folder, right?
Right.
Oh, okay. I confuse matters by calling this guy file path, same as shadowing that one. So, but I could just say child or a file path maybe. So it's different. I think that's actually okay, because if I call calc disk usage.
Don't forget to change it on line 19, Toby, before you forget.
Thank you very much. Yeah, I have been confused. Okay, so if I call this calc disk usage on this a file path, this file path corresponds to the node modules folder, and I'm calculating the disk usage only for the stuff inside the node modules folder. I think that's okay. That doesn't confuse it with other stuff that's in my top level directory. Does that make sense? But there's one thing I want to do, which is stop the top level traversal from drilling into the node modules folder, because I have a separate function that does that. Right? Does that make sense? And I think so. I think this is fine. I think this works.
But can you scroll down just a minute? I might be missing something. Yeah, I think because you're not recursively calling that arrow function on line 32, it's only going to be able to measure the top level directories in node modules, right? But don't you have to actually like dive into each of the subfolders and like measure each of the files?
That will already be done because the traverse function does that. Oops. The traverse function, if implemented correctly, should guarantee that this visit function gets to visit every node within the subtree.
Gotcha. Okay, that's the part I was missing. Sorry.
Mm-hmm. Yeah, it's a little weird, like switching back. I think the mentality you like when you're using the visit function, you just need to assume the traversal is always going to be done for you. Whereas if you're traversing yourself, then that's not the case. You have to do the recursion. But basically, by making this visit function work, we have to increase the level of abstraction such that the user of the traverse function doesn't have to worry about recursion.
Yeah, that totally makes sense. I get it.
Yep. Cool. So what's happening in here, and also if anybody wants more clarification, I'll try my best. Just ask me more questions. But the way this works is we're gonna start at this top level directory. I have a project called ng2a binding. I'm gonna dive into it, and I'm gonna assume my visitor is gonna visit every single node in the directory tree in a depth first manner. But I can, when I hit a directory and I want to disable the traversal of this traverse function, I return false. And then so I'm telling the top level traverse function, don't go any deeper if you see a node modules folder. But then here I'm calling another traversal. I'm starting another traversal that does go into the node modules folder myself to calculate the disk usage. And then if it's anything else, I'll just let the main traversal function do its thing. That way it'll find if there's like a nested folder that has another node modules folder, it'll be able to find it. So yeah, so let's see if this works. So here I'm gonna say found. Let me do this syntax. Found node modules folder that which uses size. Oh, I'm gonna need the visitor to be async as well. Which is fine. That's allowed. Okay, maybe I'll do that. Okay, it's going. I don't know how long it's gonna take. Oh, not too bad. Okay, yeah, so we found this node modules which uses that much space. That's cool. If I wonder if I do it at the top, the parent directory, it's actually gonna go into a lot of little projects I have. Each one might have a node modules folder within it, and then it will end up. Oh, what's going on?
Oh, do you have some symlinks happening?
There might be a symlink, yes. I think yes, because Power BI JS, and then Power BI. Yeah, that there might be a symlink. This is like infinite. Oh no, wait. It eventually goes into an index. This does look very much like a symlink, though. So there's a way when you do a there's a way to tell it to not follow a symlink, And is it this one? Oh. Oh, it might be instead of using stat, maybe I should use lstat. Let me see. Retrieve the stat for the symbolic link where stats is. Lstat is identical to stat, except that if the path is a symbolic link, then the link itself is statted, not the file that it refers to. Yeah, so I don't want it to follow the link. Maybe that'll help. Oops. Yeah, that did fix the problem. So now it's going through all my projects and telling me if it's got a node modules folder, and if it does, how much disk space it consumes. Yeah, so that seems to work pretty well. Okay, so I guess the next thing I could do is I could maybe ask, maybe I could ask like, hey, when was this project last touched? And how can I do that? Let me see. I think just a very basic way to do it is just go through its files and ask its modified time. Yeah, let's just do that. So get project last modified, and given that project directory. Okay, so again, I'm going to use a traverse. I'll call this a file path. Let's skip the node modules folder. So like if path base name of a file path, if that is a node modules, just skip it, because I want to look at the other files. But otherwise, we can get the stat.m time, which would give us the modified time of that file or directory. Oh, I forgot. There's a syntax error here. Okay, so then what I could do is just do the sort of the oldest modified time out of all the files. So I can do last modified. Well, initialize it with like a null or something, but maybe just do if it's a file. If that is file, then I'll do this thing. So if it's a file, then I want to say if last modified is not declared, I'll say last modified is this file's last modified time. Else if this file's modified time is greater than last modified, then we will use that as the last modified time. And then after all of that, assuming all of this is happening sequentially, that's why we need to await. At the end, we should have the last or the latest last modified time out of all the files that are not in the node modules folder. Does that make sense? Okay, so maybe what I'll do here is to say, oh, let me just test this function. maybe do like just test just this one function for now. So maybe like the ng something. Okay, it gave me a last modified date, which is 2017. Okay. 2018. Okay, that sounds reasonable to me. So I have a function that can tell me the last modified time of a subdirectory, basically. And okay, so now what we could do is we could put everything together, I think, and say, hey, if I get a node modules folder, I want to find the last modified time of the parent directory, because the parent directory is the project folder. We'll just assume that. So I'm gonna do like the way you can get the parent folder is dir name. So parent dir is path that dir name of this path. So a file path. So this one will get you the parent directory of the node modules folder, and then we'll get when was the content last modified, and then we'll print it out. Let's try that. Yeah, so we have something like, hey, I found a node modules folder. It uses that many bytes of disk usage, and its parent directory was last modified on that date, and so forth. Yeah. Okay. Okay, and then we're almost there. So like, if the only thing left to do is like, if we want to actually delete that folder, I could issue a command like exec rm-r, then the name of the node modules folder. I'm not sure I want to go ahead and do that right now, but I could. So, oh, and I can await it. This exec function comes from the child process module, child processes module. And also, if you want to use the promisified version of this function, because normally it isn't, there's like a one-liner in the docs that tells you how to get a promisified version of this child process.exec function, and this is what I usually use. You also have to, yeah.
Is there a reason that you're foregoing the file system removal of directories and files and using switching to the CLI?
Using switching to a shell command? Yeah, just because. Okay, I could use my traverse function to do that too. Yes, well, you're right. But
I think it even offers a recursive delete built in.
Does it?
At this point, I'm pretty sure you're on the latest.
I didn't know that. Let's see. file system.
I've always installed rimwrap when I need to do that.
Oh, like yeah, there's a module that does that for you as well. Yeah, that's true.
But I'm pretty sure it's in the native library. I don't know it off the top of my head. I think it's like RM or
yeah, like it's RM-dir.
Yeah, and they've like moved the functions around a little bit. But
node RM-dir or remove-dir. I know the one I know is what was it called? RMFR something.
Oh, rimraf, the node module or the npm module.
Is that how you spell it?
I think it. Yeah,
this
there
one.
you go.
Yes. So yeah, this one that stands for recursive. Yeah, it's same as that, but as a node module. So you're saying there's this method, or yeah, remove dir. It can also be used recursively to remove nested directories. Okay, this is the one you're talking about, Jason.
I think so. I can't remember. There's one that they deprecated and one that isn't, but there is absolutely a way to do it. I think it's that one. That's the current one they want to use.
Okay. So yeah, so we could use this. Is it? I'm gonna assume fs.remove dir, and is it recursive by default, or is recursion a flag? Oh, come on.
It's an option you have to set.
False.
It's an option.
Oh,
okay.
deprecated. So which one do they want you to use? They want you to use RM. That's the.
Like that. Okay. Let me see.
Yeah. Remove RM-dir is supposed to not be recursive. The recursive option is deprecated. So.
Oh, this was added in version 14.
Yeah. And that's where they moved the recursion to.
I do not have 14. Okay. But
so then use remove dir and use recursive from there.
Okay, so I'm gonna rewrite it. I probably want to do a dry run first. Let me do a dry run.
You don't want to remove your operating system.
Removing that dry run. Okay, let's see. Oh, I guess the thing I actually wanted to check was like if new date. This is now, so now is new date. So if now minus last modified is greater than 2 months, let's say, or whatever you want. But I think 2 months, I have it in my notes as 1000 milliseconds times 60 seconds times 60 minutes times 24 hours times 30 days times 2. That's 2 months. So if the difference is more than 2 months, I'm gonna remove that directory. That's the plan. Let's do the dry run. So it decided to remove this directory, which was last modified in June, which is just over 2 months, and June of last year. And this one is in May, last modified in May, so we're deleting that. And this is from last year, September of last year. So yeah, we're deleting those. Maybe I should also print out if we're not removing. Keeping that. Yeah, so if you get the picture, I think. If we want to delete it, we're gonna do fs.rm on that sucker. I'm gonna assume it's that. Oh, rmdir. Oh, but recursive is a flag, so I have to say recursive true.
Yeah, you might have to throw in force. That's the other thing I call out.
Force?
That type of behavior. I think that's like an OS common flag.
Okay. Yep. Yeah. Let's just see if it actually does it. Oh, it's not a dry run anymore, even though I say it's a dry run. So, okay. It should have deleted this folder. Is that true? It is no longer there? We deleted it. Yeah, we deleted those no modules. So, yeah, so you can write a little bit of recursion to clean up your disk drive. And yeah, I think this shows that this is really similar to what we were doing last week, which was traversing ASTs. And two things are seemingly completely different, but they're so similar, like even down to the pattern of traversal that we're using and the visitor function and everything. I think that's pretty cool. Yeah, any questions at this point? No? Okay, one more thing I want you guys' opinion on. What topics would you guys like to see in the future?
I've been really liking this little streak of doing this type of stuff, honestly. I love working with, programming languages and parsing and all that sort of stuff. I never thought about using this visitor pattern for traversing the file system. That's like, I don't know why I didn't think about that, but that's a really good idea.
Yeah, I think one reason might be because there are all these tools that when you Google for how to traverse a directory, there are all these libraries that will happily do it for you. And then because you're using their abstraction, you don't end up doing it yourself. But I think it's kind of fun to do it yourself. And I mean, we're doing the same thing. We're creating our own abstraction as well. But as you can see, it doesn't actually take that much code to do at all. Like we wrote this traverse function and it's what, like 15 lines of code? It just doesn't take very much to do this yourself.